What's up guys, this is Professor Spawn. In this tutorial, we are going to start with an Hashmap demo. So in the previous tutorial, we have seen about what is an hash table as a data structure, and we have seen in the collections introduction about the map interface. So I'm going to go back into the slide which we have seen in the past. So this is the slide which we have seen for the map interface. So the map interface actually provides a functionality for the map data structure. A map data structure is nothing but an hash table. Elements of maps are stored in key value pairs, which we have seen, right? The keys are unique values mapped to the values, right? So what are the classes that implements this map interface? So one of them is a hash map. Then we have an enum map, we have linked hash map, we have weak hash map, and a tree map. So we are going to see all this one by one, right? So if you see in this diagram, the map interface extends a collection interface, right? And these are the classes at the bottom that implements this map interface. So let's go to the IntelliJ and let's develop one by one, right? So I'm going to create an hash map object here. So if you see, it actually accepts two key value pairs, right? So the key is I'm going to have a string, and let's say that I'm going to have rather string, I can have, let's say integer. And it's not integer, I can have, let's say double, right? And here what I will do is I'm going to have employee record is equals to new of hash map, right? So here I have created a hash map with the name of employee record, and I have a key as a string data type, and the value stored in the hash table is of double data type. So let's go into the Hashmap class. So this is actually calling a default constructor with a load factor of a default load factor, which is of value 0.75, and it's a float, right? So what does this load factor really mean? So whenever our hash table is filled by, let's say 75%, because the default value for load factor is 0.75f, so that would be 75%, the entries are moved to a new hash table to double the size of the original hash table, right? So it's basically says that if you specify, for example, your custom load factor of 0.80, so if you fill the hash table by 80% of the size, then a new hash table is created, which is of double the size, right? So if you see, there are other constructor as well. So at the top, you have you have a constructor with an initial capacity. So if you see that, I'm going to go back here. At the top, I have a default load factor of 0.5f. Also, I have a default initial capacity of 16. So this is basically, if you do this operation, this is bit shift operation. So it will give us the value of 16, right? Also, the maximum capacity would be this. This is the maximum capacity for the hash table. So if you see at the constructor, then you can actually pass the initial capacity. Let's say I can pass 10 as a value, right? So this is going to pass the initial capacity for hash table, or for this hash map, would be 10 and not 16. Also, there is one more constructor with two arguments as initial capacity and load factor. This means that I can pass the initial capacity of 10 and I can pass the load factor of 0.80, right? So 0.80f, right? So because the constructor actually accepts float. So I'm going to have this f, right? So this is all about hash map. So I'm just going to keep the default value, because default value is the optimum value from the JDK8 itself. So let's put some record into this employee record. So I'm going to put some employee record using the method called as a put. So the keys are string values. So I'm going to put the names of the employee. So I'm going to put John, and then the values are salary. So I'm going to put the value, let's say of 10,000, right? So instead of double, for simplicity, I can keep it as integer. You can keep it anything you would want. So I'm going to put integer. Again, I'm going to create one more employee record, and in this, I'm going to pass Henry as a name. And here I'm going to place the employee salary as to 2000. This is for our understanding. So let's print this out. So I'm going to print this out, employee record dot toString. So when you run this code, you'll see that the hash map has the key value pair, right? So the first key value pair is John with a salary of 1,000. Then we have an Henry with a salary of 2,000. Also, let's try to get the employee record dot get. So as I told you, right, if you want to get a salary, so this is basically an hash table of name and a salary of integer type. So basically when you want to get the let's say the salary of John, so what you need to do is you need to do a get operation with a key value of John, right? And if you run this code, you will get the value as 1,000. Also, there are other methods where you can see that employee record dot, you can clone. The clone basically actually clones this hash map into a new hash map. So you can do that. Also, there is one more method called as get or default, right? So get or default John. So in this get or default, you can pass the key. Along with that, you can pass the default value of, let's say, I'm going to pass it as 1,500. So what does this mean is, if this key is not present, then return the default value. For example, here I can pass Johnny, right? So we haven't put any record for Johnny. So if I do the get or default for this key, right, as this key is not present, so it will return 1,500. So I'm going to run this code, and you'll see that the value returned for this key is 1,500. So normally we don't use get or default, right? We normally use get to get the values for a particular key, and we use put for John, right? So let's say that I'm trying to again put the value for John as a new value. Let's say that this time I'm going to put 1,400. I gave him an increment, right? So this is basically kind of an increment. So I'm going to remove this line get or default, right, for simplicity. And I'm going to format this string, right, this as out for this. Salary of John is, you can do this. So let's run this code. So I'm going to run this code, and you'll see that the updated value for John, for salary of John, is 1,400. So what happened is, if you put the key, right, if you are entering the data inside an hash map with the key value, and again if you put the same key, right, so this will actually update the value, right? It won't create a new key value pair, rather it will update the same John key which was present earlier, because the hash of this key will match with the hash of the John, and it will just update the value, right? Also, if you want to iterate through this map, you can use for loop, and we were using iterator for linked list as well as for array list. For this, we have an entry, right? So you can do that map.entry. You need to pass the arguments as string, comma, integer, not arguments, but rather parameter. I'm going to have an entry. So, and at the right hand side of this colon, you need to pass the hash map, right? So this is the hash map, and you need to actually also call the entry set. So this is basically like looping through an hash map. So how do you loop through an hash map? You actually create an entry object here, right? And you call the entry set. We have seen for the array list and linked list where we used the iterator. So if you see here this entry set, right, the entry set will actually loop through each record inside an hash map. So let's try to print out this, the entry, right? If you print out the entry, you'll notice that this is actually printing each record, right? So if you want to get the value here, you can get that. So I'm going to have entry.key, and I'm going to concat this, right? Entry.value here. So what this entry is actually giving us is each record, right? This is looping through each record, and I can get the keys I can get the values. And if you run this code, you'll get the value as John and 1400, right? Instead of, you can also do something like this. So I'm going to use format and entry string comma integer, because this is what I have defined for the hash map, right? This is generic, and I'm going to have again an entry, and instead of this I'm going to have employee record dot entry set if entry. So let's say that if entry dot get key, so as this is string we can use equals John. You need to update this hash map. So for example, I can do something like this. So entry dot get key comma, I'm going to update its its salary to, let's say, 2000. You can do that. And let's try to print out the value here. So I'm going to print out the employee record. So let's run this code and you will see that this is going to print out the updated value for John as 2000, right? So this is why the entry set is used to loop through the hash map. So this is all about an hash map where you did the put method, you did a get operation. There are also other methods like you can get the employee record dot size. You could also do something like employee record dot is empty, right? It will actually check whether the hash map is empty or not. You could also do something like employee record dot. You could check all this method. There is also something called as put if absent. So basically, you can do, let's say that put if absent is like if the key is absent, just put, right? So this is what it does. If you go into this method, what this will do is if the key is absent, this will actually enter into the database. So let's say here I'm passing 2500, right? And let's try to print out updated hash map. So I'm going to have this updated hash map, right? So I'm going to channel this up, and here I'm going to have an employee record. So let's run this and see what is the output for the John. So if you notice, it's still 2000 because John is already present. So instead of that, what I will do is I will use this Johnny, and when I run this code, you will notice that it has now 3 entries, because put if absent will only update the record if the key is not present previously. Also, I'm going to do one more important stuff here. So I'm going to pass the null value. Let's say what happens when you pass a null value. That is still quite possible, right? So if you run this code, you will notice the output as null. So an hash map has a null key as well as null value. So that is the thing you should keep in mind, right? Hash table, for example, let's say that there is hash table also with a key value. So I'm going to have, let's say, string comma string, right? I'm going to define this hash table is equals to new of hash table. And if I try to get the value for this, keep in mind, right? So there is also a raw hash table. So let's define one hash table and let's see what is the difference between the hash map and a hash table. So I'm going to create a hash table here with a value as string comma string, and here I'm going to do an sout hash table dot get null. So let's run this code. If you run this code, you'll notice that it is giving me an error called as null pointer exception. So what does this mean is, at this line, when I'm getting for the null value, it's giving me a null pointer exception. So a hash table cannot have null key as well as null value. So you should always use hash map when you want to deal with key value pairs. This is the first choice for having, a key value pair, a data structure, right? So I'm not going to go deep into the hash table because hash map and hash table are quite similar. So also, let's try out some other methods as well. So there is this get, then we have a put if absent, we have put is empty, we have seen about size, and we have get or default, we have compute if present. We don't want to do, okay, there's one more thing called as contains key. So basically if you see this contains key, so what this will return is whether the key is present or not. On the similar line, it also check for employee record that contains value, right? So I can pass, let's say, 1,000. And if you run this code, you will see that it will return whether true or false. So John is present, but 1,000 is not present, right? So if you see it in this hash table, we have 2,000, 2,500, as well as 2,000, but we don't have 1,000. So that's why this has written the false. So this is all about the hash map as a demo. In the next tutorial, I'm going to come up with a new map interface, right? So, okay, so before I, conclude this, there's one more important thing I need to tell you. So here I have specifically used Hashmap, right? So instead of Hashmap, I could also use map. So remember this, because the Hashmap is actually implements the map interface, right? So if you see here, this Hashmap class actually implements the map interface. So you could have here Hashmap, right? Instead of Hashmap, you could have here a map. So this will also work fine. Similarly, I forgot to tell you about the string. So you could also define a string. List of string is equals to new of array list. So why this is important is, let's say you implemented a list data structure, and someday your manager says that you need to make your, the list synchronized. So how will you do that? So instead of changing each and every code, so let's say you did here something called as array list, right? And he says that you need to make each and every operation as synchronized. So the data structure for that is vector, right? So in vector, every operation is synchronized. So what you need to do is you need to change here as a vector, and then again you need to change here as a vector, right? So what if you only have here as list? The only thing you need to change is this vector. That's it. Everything remains the same. So this is the base of all, like list, and then we have a map. So I'm going to remove this. This is the important information I wanted to give you. So I'm going to conclude this tutorial, and I'm going to catch you up in the next tutorial with new topic. Till then, goodbye and see you.